Right, my video cut. I had a power shortage. Right, I'm sorry for that. Let's continue. I was explaining the formula over here. This formula we always going to be given, and it is the formula that we always going to use to find the velocity. Meaning, if here we have a velocity like this, it means here we're going to have the height of mercury, which is always going to be given, and we're going to have the density of mercury and the density of the type of fluid, right? Okay, the most important thing I actually wanted to explain is air. When we are given air, sometimes air they use it on a craft. They use the speed of the craft is measured with a pilot tube. That's one thing we have to know. So we're going to have this is the height of air, height of fluid, then this is the density of the type of fluid. Use if it's oil, it's going to be oil. If it's water, use water, and this is the density of air. All right, we're going to have this formula when we work with air, right? When we're not working with manometer. Sometimes they give us equation about manometer, sometimes they give us equation about air. We're gonna do one and you will see what is happening. And when it comes to air, we know that those who are doing power machines, we know that we have what the formula that says that PV, pressure equals to volume, pressure multiplied by volume equals to mass RT, right? We know this formula from power. What do we know about density? We know that density equals to mass over volume. Then if we divide here by volume and we divide this side by volume, we're going to have our mass over volume here, which this is our density. Can you see it? This is our density. Then we're going to have what? Pressure equals to, we make this density RT, you see, then we divide by RT, then we divide by RT, then it means we have density equals to what? Pressure over RT. This is another equation you're going to use, so you must know how to derive this equation. You're going to be given the density, you're going to be given R, you're going to be given temperature at that point. Then you always have to use this equation. Then it's going to give you the pressure, then it's going to lead you to come and it's going to give you the density. In fact, this is going to be density of air, which is this one over here. Can you see it? Then the pressure, they will give you R and T, they will give you, then you substitute and you put it over here, then you get your answer correct and precise. All right, another equation that we need to look at on pilot tube is this one. A stagnation point, PO, equals to stagnation point equals to pressure in the pipe, right, and plus density multiplied by V squared over 2. You see this? Remember here at stagnation, I just forgot to explain this equation when I was busy with stagnation here. You see here at stagnation and here at the pressure on the pipe, we're always going to say pressure at what? Stagnation equals to pressure in the pipe plus P multiplied by V squared over 2. This is the equation we're going to use as well. So this equation should be given. Just check on your formula sheet how many are you given and which not you're not given. So I need us to continue and look. So this is the end with the pilot tube. Whenever a question comes with a pilot tube, you just have to nail it. Can you tie a paper for me? I just need us to do number 1 or 2. We can do both if we are fast. Just need a paper so we can start working on it. Let us do number 1. I can take a screenshot. Let us do number 1. On number 1, they say that a pilot tube is placed in the center of 150 diameter of pipe. So we have D of pipe, which is 150 millimeter, and they say that carries 44 liters per second. This is what volumetric flow is. It's Q, and which is 44 liters per second. of oil, you see our fluid, then it's oil, we know we're gonna have the density of oil. They say oil having a relative density of 0, it's a relative, remember, if it's a relative 0.8, we multiply by 1000, then it's gonna give us 800. And they said the tube has 2 orifices, one pointing upstream and the other perpendicular to it. The mercury manometer, they're speaking about mercury manometer, connecting these 2 orifices shows a different height. So we have a height of mercury. It's what? 0. Height of mercury difference is 0. It's 50 millimeter, right? But take the mean velocity in the pipe. They say mean velocity in the pipe, s 0.8 multiplied by, they say, central velocity. So the velocity in the pipe, they say we must make it as this. So it means the velocity that we get after calculating the height, we have to multiply it with 0.8 to get the final velocity, you see. So then they say calculate what? The coefficient, calculate the coefficient of the meter. What is that? The coefficient of meter is what? They need us to calculate C, right? Remember, velocity equals to what? Equals to C 2GH. So they want us to calculate what? C. Can you see that? They want us to get this. But we can't have we can't calculate C without having velocity, without even having a height. And we know that if that is the case, we have to look at this equation over here. If we say V squared over 2G equals to height of mercury into pressure of mercury divided by density of mercury and density of fluid minus 1 close. Can you see this one? So it means we're gonna use it to find what? Our velocity. We're going to use it to find our velocity. All right. We're going to use it to find our velocity, meaning with that on the picture, this is what we're going to do. Just want to look at something over here. Okay, if we look at closely, one thing I need us to note is that remember here we're going to have this velocity, and you see here they gave us Q. If we given Q, it means Q equals to area multiplied by velocity. So we don't have to use this to find velocity. This we're going to use it to find height over here. So we're going to say height equals to what? H mercury into P mercury over P fluid minus 1. Then height equals to, we are given this for mercury, is they say it 50, then it means it's 0.05. You divide it by 1000. And for mercury, what is the density of mercury? Is 13,600 divided by oil, it's 800 minus 1. Then our height is going to be 0.05 into 13,600 divided by 800 minus 1 close bracket. This is our height. Our height is 0.8 meter. Can you see our height, right? Then we're going to now find our velocity using this. We know the area and we need this velocity. Okay, here is going to be 44 liters per second. It's fine. Then we're going to divide it with what? We're going to divide this with the area. Let's find the area on the side. Over 4 d squared, right? Then the area is pi over 4 over 4 multiply d. Our d is 0.15 squared. Area equals to shift pi over 4 multiply by 0.15 squared. Can you see that? then it means our area is 0.0177, you see, a meter squared. This is our area, this is our area. And remember, our Q, we just use it as liters per second, it's fine. Then we're going to divide this with our Q. Volume equals to Q over area, then it's equals to 44 divided by 0.0177. We're going to have a very big velocity here. Is 44 the answer. It means our velocity is 2489,89. Then if we have this velocity, remember they told us this velocity is 0.8 times the central one. Then we multiply this, we say velocity final equals to 0.8 multiplied by this 2489,89. You see it? Then we multiply it like that. I'm surprised with our velocity. Why is it so large? Is it too much meters per second? This is a very high velocity, very high. All right, but it's fine. This is how you have to work out your problem. And we come to substitute our velocity here is to c over 2gh. I'm just trying to show you how we work out these things. Then c equals to v over the root of 2gh, right? Then you can start substituting. Your velocity is 1991 meters per second into 2 multiplied by 9,81 multiplied by height. Our height is 0.8. Then our c should be okay, so our c is 502,54, which I think this is not okay. What we should have done is that we should have taken this, we divided this 44 with 1,000, and it's gonna give you a velocity of 24. Then after it gives you a velocity of 24 meters per second, you divide it with 0.8, it's gonna give you 19,1. Then you're going to use 19,1, and here we're going to get something like 0.52. Just work out on that. For the sake of time, this is how you have to work out your problem. This is only one thing I think we have missed. Let us look at the, this was the, guys, here we're trying to get the average velocity, right? So then the velocity of the central. So let us now go look at the other solution. Let us look at number 2, and I show you how we have to do our number 2. Or let me explain the Venturi. Then after I explain the Venturi, we're gonna come back to do number 2. Okay, we're gonna do it together, and we do it right this time. All right, let's go. Okay, we're done with pilot tube, and this is everything you have to do with a pilot tube. Let us look at the orifices. When we look at orifices, this is one thing you just have to know. Orifices. When we look at orifices, we always work on the something called, I'm sorry for that. We always work on something called the 3C, right? We always work on the 3C. In order to find your 3C, remember your 3C is what? Coefficient of velocity, coefficient of contraction, coefficient of discharge. We always work on it. I always write this Q equals to area multiplied by velocity. When you look at Q, you know this is the discharge. This is the discharge, right? And when you look at A, you know A means area. It means the area of something. When we talk about something like orifices, we talk about, let's assume this is our tank, right? And here there's a pipe coming out like this. You see, at this point, this is our point of orifices. Then we look at how much amount is this fluid being discharged. This is our Q, and at what area, which is I call it contraction. So our area, it's your contraction, right? Then velocity, at what velocity is it leaving the orifices? And this velocity, you always name it velocity. So you're going to have your three C's. Number one C is what? Coefficient of discharge. Is your coefficient of discharge. Then how are you going to name it? You say it's a CD equals to what? Q actual divided by Q theoretical. Right? I think on N5 you are not given these equations, you're only given on N4, so you have to know them. So this is the easiest way to memorize them. Then you go into contraction, then you say C contraction equals to what? Area, because you're working on area. It's what? It's area. It's a C of area, C actual. We are working on contraction. It's a C actual. It's a C actual divided by C theoretical. You see? So this is what coefficient of contraction. It means contraction means how the size changes. Then we go to number 3 is coefficient of velocity. So on coefficient of velocity, you're going to have CV equals to what? Is going to be CV, then it means it's V actual and V theoretical. You see how these things, you just memorize them. They are easy to be understood if you just know what, you're working on a discharge. It means this is the coefficient of discharge. Then you do the volumetric, the flow of actual and the flow of theoretical. Then you come to coefficient. Then you do what? The coefficient of contraction. You do the C actual and the C theoretical, and you do to velocity CV, V actual and V theoretical. Then you are done with them. And one thing about them that you always have to know is that when they talk about orifices, they always like to ask you about the laws. They will ask you about the laws, and when you are asked about the laws, always give them what they want. Always. Let me just go to the next page so that I can write the equation for you. When they want you to calculate the laws throughout the orifices, you're always going to give them the height. What is the height? When you have an orifice and a tank like this, and this is your point of your orifices here, you come, maybe this is the surface of the water, of the fluid, to this point and to the dentum on the orifices. This is your height, you see. So you're always going to give them your height, 1 minus CV squared. What is CV? This is the coefficient of velocity. It's a coefficient of velocity. How do you get coefficient of velocity? To get coefficient of velocity, you need velocity actual and velocity theoretical. Then you're going to get your loss, right? Yes. Then another thing that they're gonna ask you about is a Venturi meter. Venturi meter. So with orifices we are done. There's not a lot of things about orifices. Same thing, there's not a lot of things about Venturi meter. Most of this chapter actually works a lot on a pilot tube. They're gonna give us Venturi meter. When we look at Venturi meter, they're always gonna ask us to find them. They always before I come to the Venturi meter, I need to explain orifices on a plate. Orifices on a plate. Orifices on a plate. Orifices on a plate. When we are given orifices, let me say this is the pipe, right? And they're gonna put a plate over here, and our plate is going to be designed so that water can pass through here. When we are given orifices on a plate, this formula will always apply. They're always gonna ask us to calculate a flow volumetric flow, where our Q equals to C, and we're going to say this C, it's a meter coefficient. They're gonna tell you, or they're gonna ask you to find it. It's a meter coefficient, and your small a, this small a, it is the orifices area. You see here on the plate here, this area is the one actually they will ask you to calculate. They're gonna give you diameter or radius of it, and you're going to open your brackets like this. I think this formula is on your formula sheet. G and H divide by 1 minus area squared over big area squared. The question comes, what is this area, this a squared mean? The big A. This is your A for the pipe, for the whole pipe. This is for A, and this one here is for small a. Can you see the difference between these two? How to get your height? To get your height, you need to find the pressure difference between the pressure of the pipe and the pressure applied sheet. Means you're going to have pressure 1 and pressure 2 over here, which we worked this on a pipetted tube. Then it means your height is going to be P2 minus P1 divided by rho G. This is how you're going to get your height, right? So we are done with the plate, and let us look. I'm just giving you formulas so that we can rush back to make one example. On a Venturi meter, they're always gonna ask you maybe the height. Whenever they ask you a height, it's something that you already know. They're gonna ask you using this equation P1 and P2, and they're going to say rho G. I think this equation is in you already seen it on a pilot tube. You already see this equation, and they're gonna say fluid over here, and they're gonna say -1. This is the Venturi meter. The only thing they're gonna ask you about this is this. Usually this will lead you to find this. They always tell you, actually it's a confirmation that these two are the same. These two are the same. These two equations. These are the two equations they're always gonna ask you on a Venturi meter. I'm rushing so that we can do the second example on that activity. I need us to do number 2 here, because I've seen it. It looks interesting to do it. It comes with a different package. Can you all see it? We're going to do number 2. They said on that number 2, this is what they said. They're saying a pilot tube is used to measure the flow of oil. So we know our fluid is oil, and is given with SG is 0.882. That 82 you multiply by 1,000 is going to give you 820. That is the density of oil in a pipe with a diameter. Then we have diameter of pipe, which is 100 millimeter, and the pressure measured by pipetted tube. Then we have pressure measured by pipetted tube. So we have pressure of pipetted tube. They say it's 400 kPa, right? And whereas a static pressure gauge, and we as well have a static pressure gauge. So it means we have pressure at 1 and pressure at a static, then which I name it PO. I can name it pressure at the static, which is 390, you see, kPa. Then they said 2.1, they say calculate the volumetric flow. They need Q in the pipe if the coefficient of pipetted tube is unity. The reason I want us to do this is to explain this thing. The pipetted is unity, then we're gonna write unity here. When they say unity, they actually saying that your constant or your coefficient, it's 1. It's actually 1. They say the average velocity of flow is 0.8 of the central. So it means when after we get our velocity, we're gonna multiply it with 0.8, then we get the actual the the average one. It means velocity average equals to velocity multiplied by 0.8 is the velocity you're going to get over there, right? Then this average velocity is the one we're going to substitute over here. So first of all, we need to look at the velocity indeed, right? And when we look at the velocity, we have this. We know we have this, right? 2gh, but we don't know the height. We know we can find this is 1, this is, but we don't know the height. So we have to go and look at what, and look at the height. And if we see we haven't been introduced to Mercury. Can you see the equation never told us about Mercury? It means we can't use this equation, height of Mercury over fluid of Mercury into density of oil -1. We can't use this because the equation did not tell us anything about Mercury. What are we going to use? We are given pressures, the pressure different. They told us about the pressure different. Then it means it's pressure pressure 2 and pressure 1 into plus density multiplied by v squared over 2. You see this equation? This is what we're going to use because we have two pressures. Then here we're going to have pressure of 400 and we're going to have pressure of 390 plus. Then this is the density of oil, which is 820 multiplied by v squared. We need that, and this is our 2. Then our v squared equals to I'm going to take this side. It means it's 400 subtract by 390. Then I multiply it with 2. Then multiply with 2 is 20. Then I divide it with 820. 20 divided by 820. 20 divided by 820 is giving me 0.024. Then I square it. It gives me 0.024. Then I can make a square root. Then my v is my velocity is times 2 over 820. All right, then okay. All right, okay. One thing I need us to look at and confirm, when we are using this equation, right, we don't substitute our density as 820. We always use it as a relative. Here we use it as a relative. Can we see that? We use it as a relative, meaning it's supposed to be 0.82. Supposed to be 0.82. So we use it as a relative. So it means we're going to have 4.9 here. We're going to have 4.9 meters per second, and we have to substitute this here. Then it means our V average, it's 4.9 multiplied by 0.8, and we get 3.95. Then we can now take our Q over here and we say pi over 4 multiply our D was what? D squared multiplied by V average. Then our pi over 4 multiplied by our D. What is our D? Is 0.1, right? Multiplied by V average is 3.95. Fantastic. Then we can find our Q. This is a squared 3.95. You see? Then this is 0.031. You see? This is 0.031. You remember the first one we did, I told you that 44 need to be converted, need to be divided with 1,000. We're gonna get the right answer. I just confirmed with it. It's supposed to be like that. This is our Q. And on number 2, they are looking for okay, let's look at number 2. Number 2, they said we must find the height, right? Okay, on a height, this is what you have to do. Remember the equation. Now you have the velocity over here. So the equation says v2 2g equals to height of Mercury. They need height of Mercury into density of Mercury divided by density of oil minus 1, right? So here you're going to substitute 3.95. Don't make mistake, right? No, we don't have to substitute 3.95. Ask me why. When we usually do this, we have to substitute 4.9. We have to substitute 4.9 here on velocity, because this one was the average, is the central velocity. We don't want to use the central velocity. We need to use mean velocity. So we use 4.95 squared into 2 multiplied by 9.81, then equals to height Mercury. Then this is 13,600 divided by 820 minus 1. Then my height is going to be, I do this, it's 4.95 squared divided by 2 times 9.81. Can you see that? It's 1.25 divided by, then I divide it with this. It's 820 minus 1. It's 15.9,6. Then I say 125. Answer is giving me, yes, our height is right and perfect. It's 0.08 meter, meaning when you multiply it with 1,000, it's going to give you 80 millimeter. This is your height, and it's perfect. All right, thank you very much. Just go solve more of these questions. This is one of the chapter that is coming on your exam, especially the tube part. Just have to know how to solve most of them. Thank you very much.